Hello student, to the Foundation of Classical Electrodynamics course. Under module 4 we have lecture 65 today, and this lecture basically we will try to understand Maxwell's equation once again. Last day we discussed few things, but a complete overview we will like to I would like to provide to understand this Maxwell's equation in terms of scalar and vector potential. So, let us start. So, we have class number 65. So, quickly recap what we have done. So, I should say that this is Maxwell's equations, understanding of the Maxwell's equations. So, Maxwell's equations a complete overview. Okay, so let us start with the Gauss's law. Quickly, I remind. So, what Gauss's law says? In Gauss's law electrostatic, we had E dot ds is q enclosed divided by epsilon 0, that is 1 by epsilon naught integration of rho dv over v. So, the total amount of flux, electric flux, is q enclosed divided by epsilon 0, and in terms of rho it is this one, and from that we had that divergence of E dv, Gauss's law, is equal to integration of rho by epsilon naught dv, true for any volume, and then eventually we get the equation, Maxwell's equation 1, and that is divergence of E is rho by epsilon naught. That is our first equation. What about the second one? Second one is Gauss's law in magnetostatic. And that basically tells me that the closed line integral B dot ds, that is the flux, is 0, and that tells me like that magnetic monopole does not exist. And we had an expression from here that the divergence of B should be 0, that is our equation 2. Then we had the Faraday's law. Which says that EMF can be generated due to the rate of change of magnetic flux in a closed loop. Mathematical statement is this, and if I want to write in integral form, it should be E dot dl is equal to minus of d dt, and I should have B dot ds where this is a surface integral. So that eventually curl cross E over ds dot ds is equal to minus of del b del t dot ds, and we had our third equation which is saying curl of E is equal to minus of del b del t. That is our third equation 3. What about the final equation, fourth equation? Fourth equation is essentially the Ampere's law modified by Maxwell's. So we had Ampere's law with a modification by Maxwell. And what was that? That was b dot dl in integral form, that should be equal to mu 0 I enclose. This I enclose is now containing two terms. One is, so I should write, one is I conducting and another is I displacement. So that eventually gives us the fourth equation, and it was curl of B is equal to mu 0 j plus that modification mu 0 epsilon 0 del E del t. That was the expression we get. So these are the four equations written in green color are the Maxwell's equations starting from the fundamental laws. Now let me write these four equations together. So if I do, then again I should write Maxwell's equation. So first one is E, which should be a function of r and t, that is rho function of r and t divided by epsilon naught. Second equation dot b. Now E and B, I just put a space time dependency. This depends on space and time. Third is curl of E is minus del B del t. It is a function of r and t. And finally curl of B is mu 0 j, which is a function of r and t. This is source term plus mu 0 epsilon 0 del E function of r and t dt. So here in this equation, if you note carefully, these are the vector equation. All these four are vector equation, and this vector equation should have some component, and component wise if I write, So, the unknown here is 6, because if I write in component wise, then it should be Ex, Ey, Ez, Bx, By, Bz. So, unknown, there are 6 unknown in this set of equations. Six unknown, and these 6 unknowns are essentially Ex, Ey, Ez, that is one set, and another is Bx, By, Bz, these 3. So, this is 3 plus this is 3. So, total 6 unknowns are there. Now, the number of equation, if you look, there are 8 equations. So, 8 equations are there to solve 6 unknowns. That means there are certain equations which are not independent. So, how many equations are there? So, there are in general, I mean in component form, there are 6 scalar equations and 8 scalar equations. There are 8 equations. So, how will you get these 8 equations? Because this is a scalar equations, if you look carefully. So, this is one equation, this is a scalar equation, this is one equation, this is a vector equation. So, component wise, if you write, there should be 3 equations, and this is also vector equation. If I write component wise, Bx, By, Bz, if I try to write in this component form, there should be 3 equations. So, 2, 1 plus 1, 2, 3 plus 3, 6, 6 plus 2, there should be 8 equations. So, among 8, I should write there are 2 scalar equations, these 2 scalar equations are this and this. If I expand this, it should leads to only one equation. If I expand this, it should leads to only one equation. So, only 2 equations are there, and there are 2 vectors equation which leads to. So, there are 2 vector equations which leads to 6 equations. Which vector equations? Curl cross E is minus of del B del T. Left hand side is a vector, right hand side is also a vector. So, component wise there will be 3 components. So, 3 equations are there. Here we have curl cross B is equal to mu 0 j plus mu 0 epsilon 0 del E del T. So, this belongs to one equation and this belongs to 3, this belongs to 3. So, overall 8 equations are there. So, there is a, I mean now the question is 8 equation and 6 variables. So, that means there are some equations which are related to each other. So, there is a connection. So, you should note that. So, there is a connection between the 2 source term here, rho and j, right. They are not independent and they are related to the well known continuity equation. So, they satisfy this equation, they satisfy this equation. So, that means they are related, they are not independent. These two are not independent. Since we have a relationship between rho and j, so this 8 equation now reduces to 7 equation, because one constant equation is there, one constant is there. So, now still we have one one equation that need to be correlated, right. So, 6 equation and one constant 8 equation, and then we have one constant, it becomes 7 equation, but I need exactly 6 equation because we have 6 unknowns. So, the other constant is something quite interesting, and that is we are having a continuity equation that we get from our electrostatic, the concept of the electrostatic problems. Now, one can expect, now there will be in principle there will be a similar connection between the something called magnetic charge and not magnetic charge, it is called magnetic charge density, like the electric charge density, like magnetic charge density obviously, which happens to be 0. We know that there is no magnetic charge which happens to be 0. Because we know that there is no magnetic charge, but if it is there, then there should be a similar connection between magnetic charge density and the magnetic current density. Which is also 0, because we know that there is no magnetic current. So, now if so that means I supposed to have a expression like divergence of J magnetic plus this is the magnetic current density, and then I have del rho magnetic del T equal to 0, but these are not there. I mean, this is not both are 0. So, in the equation, then how the equation look like? Then the equation was something like divergence of B. Now it is 0, but if I have that, it should look like this. And another thing, divergence. So, another thing is J here. So, I should have curl of E which is now minus of del B del T, then maybe we can have another term like mu 0 J M, like the way we had here mu 0 J we should have, but these two rho m and J m both are not there, it is not present in reality, but still we have a equation 0 equal to 0. So, that makes another constant. So, the first constant is the connection between rho and J, which is very much there. This is the electric current density and electric charge density, but the magnetic current density and magnetic charge density should also follow the similar relationship. They should also follow a continuity equation, but in principle I mean in reality they are not there. So, in real world they are not there. So, this is 0, but this also make another constant 0 equal to 0, that also makes another constant. So, there are second constant. So, this is the first one, and we can say this is another kind of constant one can expect, one can have 0 equal to 0 by considering the magnetic current density and the magnetic charge density, which is not there in the real world, but these still I can consider as a constant number 2, and that basically makes the total number of variable equal to the total number of equation, total number of unknown variable equal to the total number of equation from these 8 equations. So, we had 8 equation, but 2 constant if I remove, then we should have 8 equation in our hand. Okay. Now, again go back to the Maxwell's equation and writing this Maxwell's equation in a homogeneous and non-homogeneous form. So, say I should write divergence of E is rho by epsilon 0, divergence of B is 0, and then curl of E plus del B del T, that is 0, and curl of B minus mu 0 epsilon 0 del E del T, that is mu 0 J with function R t. Here also I should write this is a function of R t. So, I just rewrite the Maxwell's equation once again, but this here I can see that these two equations which is sitting in the middle are homogeneous, and the equation in the top, this one and this one, are non-homogeneous because it is containing the source term. Here we have one source term J, and here we have another source term rho. So, this is with source term, with source term, and this is also with source term. So, they are in principle non-homogeneous. So, they are in principle non-homogeneous. Now, let us exhaust the content of the homogeneous equation, because the homogeneous equation are easy to deal with. So, let us try to understand what we can get from these two homogeneous equation. Already this treatment we did earlier, but let us do once again. So, I can have the divergence of B to be 0. So, that readily allow us to write the equation that B is equal to curl of a vector potential A. This is not new, we had done this earlier, but again I am doing. So, that means I can have this equation. So, this equation now transferred to another equation, and that equation is this one. So, the information what we had is the curl of B is equal to 0. I can transfer this equation in terms of curl of A, B is equal to curl of A, where we have a liberty to choose A. We also discussed this part. Now, what we do that I will put this information B equal to curl of A into the second homogeneous equation, and if you do, then let us put this information. So, what I do this, put this piece of information to another homogeneous equation. So, I start with one homogeneous equation and I get something, and then I put this information to another homogeneous equation, and then I can have, if I do, I can have curl of E minus plus del of del t. In place of B, I just simply write curl of A is equal to 0. So, this is again not a very unknown equation, because we did it earlier. So, I should write this is curl of E plus del A del t is equal to 0. Now, once we have a curl of some vector field equal to 0, we are in a position to write this vector field to a gradient of a scalar, and I can write it, this vector field is equal to gradient of some scalar, and I have phi here, where the phi is a scalar quantity. So, my E is now minus of gradient of phi minus del A del t. Okay. So, what we get so far is this. We have done this earlier, but now we are try to understand the max in using the 4 Maxwell's equation few things. So, B is now curl of A, and E is now minus of gradient of phi minus del A del t. Both the equation we derived earlier, but now I am writing again, and this is the way one can write the electric and magnetic field in terms of the vector and scalar potential. This is right. So, you can see here 6 component of B and E can be exhausted from the 4 components of A and phi. So, whatever, so if I able to, so how many components are there? So, at the end of the day I need to find E and B. So, B has 6 component, B has 3 component Bx, By, Bz, E has 6 component 3 component Ex, Ey, Ez. But from these two equation I can see that this 6 component can be compressed or can be extracted from the 4 component of A and phi, because A is a scalar quantity, A is a vector quantity having 3 component, but phi is a scalar quantity. So, A is having Ax, Ay, Az, phi is a scalar, it should only have one component phi. These 4 component are capable enough to describe E and B, where E and B are having 6 component Ex, Ey, Ez and Bx, By, Bz. Now, so what should I get? What should I write? So 6 component of E and B, that is 3 component of E and 3 component of B, can be extracted from the 4 components of the vector field A and the scalar field phi. Now, I would like to stop here because I do not have much time to discuss further, but the next day what we do, that we will continue this treatment, because we are just started to understand few things. So, we write the 4 Maxwell's equation in a form where we had 2 homogeneous and 2 non-homogeneous equation. That is the starting point here in this part. Now, we exhausted the information of the 2 homogeneous equation, divergence of B equal to 0 and curl of E plus del B del T equal to 0. And this, after taking the information out of these 2 homogeneous equation, we find that B is equal to curl of A and E is equal to divergence, E is equal to gradient of phi minus the time derivative of the vector potential A. So, next day what we do in the next class, we will put this value of B and E in this non-homogeneous equation. So, we had 2 very important equation here with having source, that is this 1 and 4. So, the whatever the information we extracted from this, we will going to put here in this equation and in this equation. What we put? We put this information that the B is curl of this information, which is B is curl of a vector field A. So, that information, and E is minus of the gradient of phi plus minus del A del T. So, we put this information in equation 1 and 4, and then we are going to check that what we have, what we get from equation 1 and 4. So, then we will see that the entire expression, all the equation will now come into the equation, now come into the form of A and phi, and then we have a different two important differential equation for A and phi. I am going to try to solve this, and from that one can extract the information of electric field and magnetic field in terms of the scalar and vector potential. So, with that note, I like to conclude here. Thank you very much for attention, and see you in the next class where we continue this treatment. Thank you and see you in the next class.